Hi folks, we're going to take a look at page 129, number 15. So here they give us this position function, but it's got this k value, which is a non-zero constant. So keep in mind that as you're working with this, all these k's just represent some unknown constant. Okay, so part A asks us to show that the acceleration is constant. Now, by this point here, we realize that we've got a polynomial function here, and we've got a quadratic. So when I take the derivative, I get a linear, which is going to be the velocity. Then when I take the derivative of a linear function, which will then be the acceleration, I should get just a constant. Okay, so let's just check that out here. So part A, so we have to find the velocity first, which is the derivative of the position. So remember here, k is just a constant, so the derivative of t squared is 2t. So 2kt plus, well, this whole expression in the brackets is just a constant, so it's a constant times t, and the derivative of t is 1. So we're just left with 6k squared minus 10k. And then here, plus the derivative of 2k, again, so that's just a constant, so the derivative of constant is 0. Okay, so here's our velocity function. So if we take the derivative of that, we get the acceleration. We already know this whole expression is going to have a derivative of 0 since it's just a constant. So here, 2k times t, derivative of t is 1. So it's just equal to 2k, which is a constant. Okay. So part B, let's see what part B asks for. It says, find the time at which the velocity is 0 and determine the position of the object when this occurs. Okay. So first things first, we need to determine when this thing is equal to 0. So I've got 2kt plus 6k squared minus 10k has to be equal to 0. So let's solve for t. So let's take the additions and subtractions to the other side. So minus k becomes 10k, plus 6k squared becomes minus 6k squared. Okay, and then here let's divide by 2k. So 10k minus 6k squared, okay, divided by 2k. Okay, now since I've stopped to work with this, I really should be simplifying this here. So t value 10k divided by 2k is just 5 minus 6 divided by 2 is 3, and I'm still left with a k. So 5 minus 3k, okay, and it doesn't give me any units, so I won't worry about that here. Okay, so this is the time at which the velocity is 0. Now they ask us to determine the position of the object at this time, so that means we got to take this expression and put it into the position function. So this looks like it's going to be a lot of annoying algebra, so probably not the amount of algebra I'd expect you to do on a test, but let's do it as a good exercise in doing our algebra correctly. Okay, so here actually we don't want s at t, we want s at 5 minus 3k, because we know the time at which we're interested in. So let's input that here. So it's k times 5 minus 3k squared plus 6k squared minus 10k times the t value, which is 5 minus 3k, okay, and then plus 2k. Okay, so here we just got to do a whole bunch of algebra and simplify. So here k times, now I don't know if you know that little trick about squaring a binomial, so let's square the first, so 25, square the last, which I'll do afterwards, and then twice the product of first and last. So 5 times negative 3k is negative 15k times 2, so this is minus 30k, and then here the last squared, negative 3k, all squared is plus 9k squared. Okay, so now we've got this binomial here, so we've got 6 times 5, 30k squared, minus 18 times k cubed. Here we've got minus 50k, and then here we've got plus 30k squared, and then plus 2k. Okay, and what do we have? 25k minus 30k squared plus 9k cubed plus all this other stuff. Okay, so since we're going to want this in order of power, let's start with the k cubes. So here we have 9k cubed minus 18k cubed. So that's all we've got. So we've got negative 9k cubed. Okay, let's do the squareds now. You've got negative 30 plus 30, well, that's 0. And here we have another 30k squared, so plus 30k squared. And let's take care of the k's. We have 25 minus 50 is negative 25, plus 2 is negative 23k. Okay, so this is the value of the position at 5 minus 3k. Okay, so again, just to recap here, the main thing was to be able to do all this manipulation and calculation of derivatives and use the derivatives as we've been doing, except dealing with this constant that shows up in the equation. Okay, and if you look at some questions further down in part C, you'll notice that this seems to be a common thread that appears when we're dealing with these physics equations. Okay, that's it for now.